Hello, chemistry students. Mr. McKay here with some helpful hints and some rules for balancing equations. Let's take a look at a couple reactions. First of all, I'm going to start with talking about when writing formulas. This even comes before you do balancing. You have to get the formulas right. So that's why we spent some time learning about crisscross and things like that. So here's the equation I'm going to have for you guys. We're going to talk about reacting hydrogen gas plus oxygen gas to make water. Now, one of the rules is if you're given a word equation like hydrogen gas plus oxygen gas, there's hydrogen gas plus oxygen gas yields water. If you're given that in words, determine the correct formulas first and then balance. So if you really get that step wrong, you might as well not even bother balancing. So right now that equation that I wrote is incorrect. Hydrogen and oxygen are both what we call Hofbrinkel. I've mentioned this before in class, but live it and love it. Those 7 elements always get a subscript of 2. When they're listed as elements, like hydrogen gas or oxygen gas. So to make this a correct formula for both of those two, that has to be the case. All right, now it says for another rule, once a subscript is written in a formula, don't change it. Meaning get those correct the first time, like I mentioned. If you forget one of those subscripts, if you're writing them from scratch, you're not going to be able to balance the equation. And then really the other rules, remember Hofbrinkel, that's diatomic molecules. Diatomic meaning there's 2's as subscripts, just for those. Now if they're in other formulas, it doesn't necessarily mean there's a 2 underneath them, but if they're written in a sense by themselves, they always get partnered up. All right, now to go ahead and balance this then, some real simple techniques. Like we've mentioned, you have to use coefficients. The number of atoms on either side has to be the same. So right now I have, if I look at my hydrogen over here, I have 2 hydrogens on the left and I have 2 hydrogens on the right. I have 1 oxygen on the right and 1 oxygen on the left. So pick an element. Usually hydrogen's the better one to pick, but in this case we're stuck picking oxygen first. So in this case we want to put a 2 in front because again of this oxygen over on this side, and the only way then to or the next step would be look at what you're attached to. So in the water molecule, not only are there 2 water molecules now with 1 oxygen in each, that would give us a total of 2 and 2 for 4 hydrogens. Well, I can fix that over here. Let me see if I can do a quick eraser here. Try to do that carefully. That's the best as I could do here. That would be the balanced equation for this quick one here. So, a couple of the rules we've already gone over. If you're given a word equation, make sure you get the formulas right. Once you have a subscript locked in place, like this 2 right there for oxygen, you can't change it again. It's the coefficients that you can change. And remember Hofbrinkel, that will help you write those formulas correctly the first time. Okay, now the second equation I want to work on, using some of these rules again, is silver nitrate plus magnesium chloride makes silver chloride plus magnesium nitrate. Now quickly, here are those formulas. Again, you're going to do crisscross to get these correct, but here's silver nitrate plus magnesium chloride makes or yields silver chloride plus magnesium nitrate. And magnesium nitrate has parentheses on it because I need 2 nitrates to create that formula. All right, now, again, going back to these balancing rules, number of atoms for each element must be the same on both sides of the arrow. Pick an element that looks easy to balance, and then check the element that is bonded to it. And basically, it's Like I used to tell students, it's like going back and forth in a tennis match. Oh, I fixed it over here. Oh, now I've changed this one. How does it look on the other side? Oh, looks okay. Back and forth until you're balanced. All right, so for instance, on this one, I would pick chlorine. Looks relatively easy to balance. I have 2 of them over here, and I only have 1 of them over here. So in order to get 2 on the right-hand side, 2 in front. All right, well, now I just changed silvers because it's attached to the chlorine on the right. Oh, can I fix it over on the left? Sure thing. Put a 2 in front of the silver nitrate on the left side. Oh, by the way, how many nitrogens do I have? Now, here's where we have another rule we can tie in. Treat polyatomic ions as one thing so you don't have to deal with every single atom separately. For instance, on the left-hand side, I have NO3s. On the right-hand side, I have NO3s. Remember, that's a polyatomic anion called nitrate. So instead of talking about separately nitrogen and oxygen, let's talk about nitrate. So on the left-hand side, I have 2 nitrates. On the right-hand side, I have 2 nitrates. So really, even though the 2's in a different place, one of them's a coefficient, one of them's a subscript, I still have the same number on both sides, so I'm good. The other rule, really the last rule, is balance oxygens last when possible. Well, in doing what we just did here, I don't have to look at the oxygens even separately. They're in that nitrate polyatomic. So if you look at what I have here, multiplying coefficients and subscripts, I have a 2 and a 3, which would be 6 oxygens. Over here, I have a 2 and a 3, which would be 6 oxygens there. Everything's balanced. So really, we've hit almost every rule that we have. Just reviewing again, pick the easiest element first, check the element that's bonded to it, and look at it on the other side. Multiply coefficients and subscripts to get the total number of atoms. Treat polyatomics as though they were one unit, and then it's a lot easier to balance. And if given the choice, balance oxygen last.